This lesson is about domain and range, understanding what their definitions are, what they are, how to identify them and write them. First of all, domain can be thought of as the x values that exist, or that are allowed, or that are defined as opposed to not being defined. By the way, things that are not defined are things like division by 0, which is not a real number, or taking a square root of a negative number, which is again not a real number. So as long as we don't have that, values are defined. The range are the corresponding y values that exist or are allowed, etc. Notation. You may be familiar with some or all of these, but I want to make sure that you've seen them. I can talk about the inequalities alone, such as this example. We read it as x being the subject, so I would say x greater than or equal to -1 and less than 2. Or maybe x is greater than or equal to -5 and less than or equal to 7. Or perhaps x is just greater than or equal to a number, as examples. These could all be with the value for y as well, for range values. Interval notation is a way of saying the same thing in a compact form. I would say -1, because that's the smallest value. 2, I'm trying to do this example here, when something is included as a value, I put a square bracket around it, and when something's not included, I put a round bracket around it. Now there's even another way to write this. I could write it as -1 with a square bracket in, 2 with a square bracket out, which is another way to say not including. Looking at these ones here, I would start from -5, a comma, a 7. Since they're both included, I would put square brackets in both directions. Now this one's a little bit trickier. This is actually the minimum value of x, 3. So I start by writing 3, and this is giving the idea that x is greater and greater and greater beyond 3 and keeps going without any boundaries. So it goes to infinity, which is written that way. Now since 3 is included, I do a square bracket. But infinity isn't a number, it's a concept, so it's not bounded, and so I use a round bracket for it. Now, set notation is an even slightly more formalized notation. If I wanted to convey this information about x, I would start by using a set notation bracket. I put x here, and I write a vertical line that's kind of long, longer than a 1, that is read as such that, meaning which is about to be defined as. Then I put that inequality information from above with a comma, and I go even further and I define what element or what set of numbers x is, and if I mean real, I use this fancy capital double vertical line r representing a real number being all decimal numbers that you know. There are also integers, whole numbers, natural numbers, rationals, irrationals, and so on. You can look up the definition of those if you've forgotten or if you haven't heard of them before. So those are different ways to represent the domain and range. In this lesson, I'm going to use the interval notation. I should just make one more note about the interval notation. It might look a bit like an ordered pair for plotting, but it's not. This is representing only x values or only y values, where ordered pairs represent x with y. It's a different idea here. Context will help to clarify. All right, domain and range identification from graphs. Here are a few graphs. We can use graphs to find domain and range values. What you should do is proceed from left to right if you're looking at domain or x values, from bottom to top if you're looking for range values. Notice that by going from the left or going from the bottom, I'm referring to the minimums, and when I go to the right or to the top, those are the maximums. What you do is you look for all the values you see. Now, we have to watch for arrowheads. Arrowhead means keep going according to a pattern. So this arrowhead here means that it keeps going to the left as well as down. Now, eventually, it's going to go to the left forever. So that's negative infinity. Since it's a line, everything is represented here all the way to 0 into the positive numbers. You see that this is identifying this point as 2 in x. This point back here was -3 for x. I've gone over here to 4 for x, and there's an arrowhead meaning keep going, and this is horizontal. It's going to keep going to the right, so it's going to positive infinity. Since those are concepts, not numbers, I'll use round brackets to denote them. Now, focusing on the range. I start at the bottom. I think of how low this goes. Well, this arrow goes both left and down, and it will go down forever. So when I think of the y value itself goes down forever to negative infinity on y. It's going up continuously, connected all the way to 1. At this point, it becomes horizontal. Notice how y is also 1 here. And the arrow means keep going according to that pattern horizontally. If it's horizontal, it will never rise or fall from here. So y gets to 1 and does not go beyond it. And it does equal 1, so I'll use a square bracket. Let's look at the next example. Maybe you should pause, try it out, and then check my work. Okay, hopefully you've given this a try now. This is a bit of a different sort of a interesting shape. I've got a curvature here that goes up to this place at the origin, which is 0, 0, by the way, 0x, 0y, and then starts falling away. It's going to the left, and it's falling according to this pattern. Well, it's going down, but it goes left. So in terms of x to the left, it goes to negative infinity. Round bracket. It's continuous and connected, so every real number is there all the way up to 2 in x, but then it keeps going, both up and right. Domain is about left and right. So I want to focus on the rightward part of this. It's going this direction. Arrowhead means keep going up and right. It will go to the right forever. Range. Range is a bit tricky on this one. What's the minimum point I see? Well, there's this place. This is low. Y is negative 2. And it grows, and it grows. But wait, when you come over around here, this starts falling away. And it will actually keep going like this, and going and going. So the minimum y is actually negative infinity. It goes down forever. So this is sort of a little tricky point that we actually don't really take into account when we're doing the range. It goes up as far as 0, starts falling away. But wait, over here, the y is 0, and then it's positive, and it goes up. So it actually will go up to infinity. Every y value is on this graph somewhere, and it only needs to exist in one place to be counted in the range. One more example. Again, maybe pause and give this one a try, and then come back. Just to clarify before you go, negative 3 represents this point here. So this point right here would be negative 2, negative 3. This point here will be negative 2, negative 2, and so on. This point here, 0, negative 1. This point's 2, 2, so this point here is 3, 2. So just want to make sure you're clear on what you're seeing. By the way, the other thing is that black dot means filled in or exists, and hollow dot means doesn't. Okay, so to do domain, I look to the left. The very smallest x value I see is negative 3 at this dot. It's a black dot, meaning included. So I do have negative 3. I proceed to negative 2. It's not included here, but if you look above, it is included right here. So I actually have negative 2. I proceed to negative 1 in x, which isn't included here, but it is included here. Therefore, there is a negative 1. Though there is no 0 here, there is a 0 here. Though there's no 1 here, there's a 1 here. Again, no 2 here, but there's a 2 here. And so this goes all the way connectedly in terms of x values as far as positive 3. But that's a hollow dot, so I need a round bracket. When it comes to range, it's a bit funny, this one. This is horizontal, so y is negative 3 the whole way, negative 2, negative 1, 0, 1, and 2. But there are no y values in between here. So y is actually just a list of numbers, negative 3, negative 2, negative 1, 0, 1, and 2. Or I could write it this way. I could say from negative 3 to 2 inclusive, comma, y is in the integer family. This means integer, positive and negative whole signed numbers. Okay, a little bit more. How to figure out domain and range if you just have an equation without a graph? Well, one way to go is graph the equation, I guess. You could use a calculator or graph paper and then do what we did above. The other way to do it is to consider where are the values defined as opposed to undefined. Remember, division by 0, not allowed, undefined. Square root of a negative, not allowed. And think about the behavior of certain math operations like square roots. Okay, let's have a look at this first one here. If I think about substituting values for x, large numbers, small numbers, positive, 0, negative, fraction, decimal, there should be no problem just substituting and then subtracting. So what this is telling us is that the domain is the element of real numbers. It's all real numbers. The range, if I wanted to do interval notation, by the way, negative infinity to infinity. The range, well, I'm starting from any number with 3 subtracted. Even though I'm subtracting 3, I'm still producing every number, so the range is also real, or it could also be written negative infinity to infinity. This one has no undefined values, no boundaries or anything else. Now, over here, a little bit trickier. Square root. I can only take the square root of positive things, or 0. So, my domain, x values, can be 0 or more. This is one way to write it. The other way to write it is 0 with the square bracket, bigger and bigger forever to infinity. Now the range, well, square roots produce positive answers all the time. The very smallest answer I can get is square root of 0, which is 0. Then I take away 3. So I'm getting progressively bigger numbers from 0 minus 3. That means y is always at least negative 3 or more. With interval notation, negative 3 square bracket to infinity. All right, that's the basics of domain and range notation and identifying them.